We're back to do some more of our rational work, and we are on 91 example D. So they're getting a little bit more complicated. It may take a few extra steps, but it's really still the same procedure. We're going to factor the numerator. We're looking for a GCF, 5y. That leaves us this. Denominator looks like 10y squared. And that leaves us with y plus 6. And the y minus 3 and the y plus 6 aren't the same, but there's some common factors we can see between the 5 and the 10 and the y squared. So if I kind of just spread this out a little bit and make those obvious factors, I can rewrite 10 as 5 times 2 and y squared as y times y. And now I can cancel funky forms of 1, and my answer is going to be y minus 3 over 2y times y plus 6. And you can leave your answer like this. You do not have to distribute this 2y back again. This is considered a simplified answer. It's perfectly fine. Number E, numerator, DCF is 5. Denominator, difference of two squares. A plus 7, a minus 7. So the two a plus 7s are exactly alike. They will cancel, and we're left with 5 over a minus 7. Now we've got two trinomials. We need to see if we can find AC partners for these guys. These are pretty easy. I think these you ought to be able to do in your head. What multiplies to negative 5 and adds to positive 4. So that's x plus 5 and x minus 1. Make sure you get these right. Go ahead and double distribute just in your head and make sure that you can get back to this original numerator. The denominator is x plus 3, x minus 1. Double distribute, satisfy yourself you've got the right factors. And now we do have a pair of factors that are exactly alike, and we have x plus 5 over x plus 3. And do not be tempted. Well, you can be tempted all you want, but just don't do it. This x and this x do not cancel. And if it helps you to keep parentheses around these to see that this is an entire term itself, then you're welcome to leave it with parentheses. So we've got a couple different kind of funky examples coming up. So our commutative property back from 7th grade says that a plus b and b plus a are exactly the same thing. It doesn't matter the order when you're writing an addition problem or multiplication for that matter. It doesn't matter what order it comes in. You have the same result. So these are the same. However, a minus b, when you have subtraction and you have division, the order makes all the difference in the world. So these are not the same. These are actually opposites. B is negative here and positive here, while A is positive here and negative here. And the way that you know these are opposites is if you added these two guys together, you would end up with 0. Opposites add to 0. So in looking at our fraction example, if A plus B and B plus A are exactly the same thing, if we write them as a fraction, then we can cancel them no matter what the order they're in and say, this is 1. However, A plus B over I didn't write this right. Let me go get my eraser. But A minus B and B minus A are opposites. So these do not cancel and divide to 1. They actually divide to a negative 1. A negative 1. So this is the rule that we're going to be using as we run into some of these opposites in the next page or so. So let's run through an example to illustrate this with numbers. I think it's a little easier to see with numbers. So if we say 5 plus 3 over 3 plus 5, that is, of course, 8 over 8, which is equal to 1. That illustrates this guy right here. But if we have 5 minus 3 over 3 minus 5, you end up with 5 minus 3 is 2, and 3 minus 5 is negative 2. So this is where you get this guy right here, negative 1. And this will work every time, every example that you do. So if you want to try another one just to satisfy yourself, 7 minus 10 over 10 minus 7 is minus 3 over positive 3, which is negative 1. So anytime you have opposites, they will divide, but not to a positive 1, to a negative 1. So we're going to have some examples on the next page with this. Let's move on. And let's run through these 6 examples if we can pretty quickly. So again, we're looking for GCFs, 3x plus 2. In the denominator, 5x plus 2. Well, let me write it the way that it's really written here. I got ahead of myself. So when I factor a 5 out, I get 2 plus x. And I notice that these are written in a different order, but because it's addition, it doesn't matter, and they will cancel to make the ghostly 1, and our answer is 3 over 5. Lovely. Next example, same sort of thing. 7 is the GCF, and we have 1 plus a. So you'll notice they're not in the same order, but it's addition, so we can cancel them. They are exactly the same terms in a different order, and our answer is 4 over 7. So these are fairly straightforward. Let me run through one more. C is the GCF in the numerator. 2 plus c. C is the C squared is the GCF, and you have c plus 2. You notice those cancel, but we can do one more step with this one because this is c in the numerator and c times c in the denominator. Cancel, we've got the ghostly 1 in the numerator, and there's our final answer. So as we move down to these last 3, we're going to get into some opposites, and this is what they're going to look like. So again, we're doing the GCF in the numerator, m, 6 minus m. In the denominator, difference of 2 squares, m plus 6 and m minus 6. So if you look at this m plus 6, it's not an opposite of this guy, but this one is. Here the m is negative, here the m is positive. Here the 6 is positive, here the 6 is negative. So these guys will cancel, but they cancel to a negative 1. So right now we are left with our answer, which is negative m over m plus 6. And it doesn't really matter if you put this negative sign with the numerator or whether you leave it out in front of the fraction. That's your answer. All right. This one is another good example of this. Let me go get a different color. A is the GCF, a minus b. In the denominator, it's the difference of 2 squares. So the squares are b plus a and b minus a. Again, you'll notice here the a is negative, here it's negative here, positive here, negative b, positive b. These guys will cancel, but their quotient is negative 1, not positive 1. So it's negative a over b plus a. And one final one, common GCF is 3. So I end up with 2 minus x. In the denominator, I can use the AC method, and I can get my factors of x minus 2, x plus 1. Make sure when you double distribute, at least in your head, you can get back to this original expression. And I'm now looking for nothing exactly the same, but I've got some opposites right here. So this guy, and it's the negative 1 that's going to come out as the answer. So his answer becomes negative 3 over x plus 1. That's the answer, and that's the end of this video. See you back.